Dear learners and viewers, how are you? I think you are all well. In the previous class, many students of my honors level have requested me to conduct a class in English. So I have a little step to conduct a class in English, and the topics is Calculus 1. I think these topics will be helpful for you in this devastating epidemic corona period. This is Gautam Vishwas, Assistant Professor of Mathematics, Government Bangabandhu College, Gopalganj. From very beginning of this class, I have to give some idea about calculus. That means what is calculus and some related topics of calculus like function, one-on function, relation, domain, range, etc. In our previous class, we have stated that if you combine some infinite small points, then it forms a surface or an area or a plane. This is the idea of integration. On the other hand, if you divide this surface into infinite small points, and then you will get small points, and this is the idea of differentiation. So both differentiation and integration are the idea of calculation, and if you have the well idea about integration and differentiation, we can easily tell that you have well idea in calculus. And this idea of calculus was vastly discussed in the 16th period by scientist Newton and Leibniz. So mathematicians and our scientists called them as inventor or creator of calculus. So what can I say now? The change of a points of integration and differentiation is the main idea of integration, and this can be expressed by some notations. So the very beginning of this chapter or these topics, we have to discuss about relation, function, domain, on function, etc. Now we want to go to board, and they are given some examples. At first, we want to discuss every function is relation, but every relation is not function. So what is relation? Please see these examples. Here, 3 items are given: wheat, paddy, and sesame. And on the second set, flour, husk, rice, husk, oil, cake, and oil. Now, you can take these 3 items as input. And if you put this input into a machine, then you can see that we will get output as flour, husk, rice, etc. So it is really true that wheat turn into 2 items, flour and husk. On the other hand, paddy turn into 2 items, rice and husk. This is input and this is output, and a processor processed this item into flour, husk and rice, and this processor is relation. So in the second example, sesame turn into oil, mustard turn into oil, mango turn into juice. Here one item and output is one item. Mustard one item, output is oil, one item. Mango one item, output juice one item. And among these examples, we can easily see that any element or any members of first set relates with one or more elements of the second set, and this is known as relation between two set A and B. So what is the definition of relation? There are two non-empty set. If in these two non-empty set, every or each elements of first set relates with one or more elements of the second set, then there indicates the relation between two sets. This is relation. This is the main idea of relation. But among these examples, if we follow these examples, we can easily see that here input is one item, output one item. Input one item, output one item. Input one item, output one item. And if these two sets in first set, we can easily see that, and we can take this first set is the son, and second set suppose they are father, and it is true that if you call Shabu, then his father Bashu will come. That means one input, one output. If Shaki is called, then Obhi will come, and if Hashu is called, then Mishu is come. That means in these cases, one input, one output, one input, one output. That means there is no two output for one input. There is no two output or more output for one input. And this is the special types of a relation, and this relation is called function. So what is the definition of function? In these three sets, we can easily see that two non-empty sets A and B are related in such a way that corresponding to each elements of first set relates with an unique element of second set. With a unique element of second set. And this special types of relation is called function. So we can easily state that every function is relation, but every relation is not function. Now we have the definition, and please see the board. The function definition, two non-empty that I have already stated. Two non-empty set A and B are related in such a way that corresponding to each element of A is related to a unique element of B. Then the relation from A to B is called a function. That means a special types of relation is function. It is expressed as the function from A to B. Here A is called domain, B is codomain, and f of is the range of function A. That means f of A is one kind of image of the set A into B. So we can also tell the range as image. On the other hand, here if the individual elements of A relates with the individual elements of B, individual and unique elements of B, then the relation will be a one-on function. That means at first the function you have to define function, then among the function you have to define one function. So these are functions, this and these are function. So among these functions we can define one function and one function. Now we have to define the condition of function, then we will define as variable of function and then one and one function. So condition of function. Condition of function, there are two conditions of function. First condition, we have already stated that each elements of first set must relate with a unique element of second set. That means you will put one input into machine and the machine will give you two output, then it will not be function. Okay, but if you input one item and if you get one output, then this will be function. So the first condition of function, every or each elements of first set must relate with only or a unique element of second set. So these and these are functions. On the other hand, if you see these examples here, image of 1 is 3, image of 2 is 4, image of 3 is 5. That means image means range of 1 is 3, range of 2 is 4, range of 3 is 5, but range of 4 is not declared here. So here is no image which can be, here is no element which can be image of 4. So there is no image of 4, so there is no range of 4 in second set. So every elements of first set doesn't take part in this relation, and so this is relation, but this is not function. So two condition 1, every or each elements of first set must take parts, and you will see that these elements must be related with unique element of second set, and every elements of first set, that means domain, every domain or every elements of first set must take parts in the relations, then we will get the function. So these two conditions of the function. Now we will define the function as variables. Suppose y equal to x is a relation. Y equal to x is a relation. Y equal to x is a relation. And if you put x equal to 1, put x equal to 1 implies y equal to 1. Put x equal to 2 implies y equal to 2. Put x equal to 3 implies y equal to 3. And more value of x. Here you see that if you put one value of x or every value of x, you get only a single value of y. That means input one variable and you get one output items. Input on and output also on. So this is a function because you put every value of x and you get one value of y. But if you take y square equal to x, then y equal to plus minus root over x. Here is a relation, and if you put x equal to 1, then you will get y equal plus minus root 1. If you put x equal to 4, you will get y equal to plus minus 2. That means one input, but you get two output. That means one, if you put any value of x, you will get two values of y. So this is not function, this is relation. I have given you two examples which is function or not, and you can easily define the function as variables in this way. If two variables x and y are related in such a way that corresponding to every value of x, you will get a unique value of y. Then the relation between these two variables, x and y, is called function. So the example before I have expressed, that example was example of function, and this example is not a function. Now one and one-to function, but at first we should discuss which are function and which are not function here. This is not function. This is not function because one element turned into two element, one element turned into two element, one element turned into two element. This is a function. One element turned into one element, one element turned into one element, one element turned into one element. That means one input, one output. But here one input, two output. Here one input, one output. One input, one output. One input, one output. Here one input, one output. One input, one output. Here one input, one output. One input, one output. So all of these except this, all are function. Now one function and one-to function. See these examples. If you call Shabu, his father Basu. If you call Shaki, his father Ravi. If you call Hashu, his father Mishu. Here you can easily observe that one element, one input and one output. That means no two elements of the first set have the same image. No different two elements of the first set have same image. But here Shabu is the son of Renu, Shaki is the son of Rina, Hashu and Hitu are the son of Salma. In these examples, you can easily observe that if you put two input but one output, that means two different elements of the set A have same image. Two individual elements of first set has the same image. This is function. This is also function. This is also function. But among these three examples, this is one-on function. This is not one-on function, and this is not one-on function. So what is the definition of one-on function? We can define in this way: any two individual elements of the first set has no same image. That means if you take any two different elements or items of the first set, then you can get no same image. This is the definition of one-on function. If any two different elements of first set have the same image, then the function is not one-on function. So among these three examples, this is not one-on function, this is not one-on function, but this is one-on function. Now on-to function. On-to function means we can easily discuss what is on-to function. See in these examples, this is the codomain of the function. This B set is codomain, of the function, codomain. And in this codomain, Shabu is the son of Basu. That means Basu is the image of Shabu. So Basu is a range. Basu is a range. Shaki is son of Obi. That means Obi is the image of Shaki. So we can easily state that Obi is the image of Shaki and Mishu is the image of Hashu. So this image Basu, Obi and Mishu, this image is range of this function. Also these three items, these three men are also codomain, and in this set 4 codomain, Basu, Obi and Mishu and Mithu, 4 codomains. But among 4 codomains, 3 are range. So we can say range is the subset of codomain, and here range is not equal to codomain. On the other hand, see these examples. Renu is the image of Shabu. That means Renu is a range, Rina is a range, and Salma is a range, because Shabu has a relation with Renu, Shaki has a relation with Rina, Hashu has a relation, Itu has a relation Salma. Here, Renu, Rina and Salma are ranges. Also, Renu, Rina and Salma are codomain. And in this case, codomain and range are equal. On the other hand, in these examples, codomain, oil and juice, but among this, with relation of these items, oil and juice is also range. So here range and codomain are equal. So if a function has the properties in this way, its codomain and range is equal, then this types of function is called one-to function. So I have given the definition of one-on function previously, and now I have given the definition of one-to function. And if a function has both types of characteristics, that means if it is one-on and if it is one-to, then the function can be turned into inverse function. Okay? Now I will give you some presentation as curve where the function is either function or relation. A relation will be either function or relation. See here, this is a curve, and this curve, if you put here x equal to 1, then you will get 2 values of y. That means 1 input but 2 output. 1 input but 2 output. So this curve is a relation, but this will not be function. On the other hand, take another example. Here y equal to f of x. Y equal to f of x. Here, if you put any value of x, you will get 1 value of y. That means 1 input and 1 output. So we can easily find out the graphical representation whether it is either function or not. On the other hand, if you take x, suppose this is a x equal to 4, this is not a function, because when the value of x is here, then you will get infinitely small points of y, that lies on this straight line. So this is a straight line, this is a relation, but this is not function. Now try to give you some examples which will be helpful for you to find the domain and also range of a function. At first I will discuss domain, then range. Our time is very short. Within this short time, I will try to discuss these topics. Category 1, general function. General function f of x equal x to the power 4 plus 4x plus 5. F of x equal cos x, f of x equal to sin x, f of x equal to e to the power x. These types of examples of a function, and in these functions, if you put any value or any real number, you can easily get the value of f of x. So it is very easy to find the domain of the function. It is very easy to find the domain of the function because these functions are defined for all the real values of x. And in these types of function, we can write in this way: the function is defined. The function is defined for all real values. All real values of x. So domain df equal r. Also it can be expressed as minus infinity to plus infinity. We can easily find out the domain of these types of function. Now, second category, second is fractional types of function. Fractional types. F of x equal 1 by x minus 3. F of x equal x minus 2 by x square minus 4. F of x equal x minus 3 by x square plus 3x plus 2. These functions are fractional types of function because there exists denominator part, and we know that if the denominator part is 0, then the function is undefined. So at first we have to find the undefined values of x, and if we deduct these undefined values from total real values, then we can easily find the defined values of x, and the set of these defined values is domain of the function. So at first we have to make restrictions on denominator part. So we can write here first function f of x equal x minus 3. Here if x minus 3 equals 0 or x equal to 3, then f of x is undefined. That means x would not be the domain of the function. Now deduct this. So what is domain? Domain of the function will be deduction of 3 from total real number I. You can also take these examples in this way. Suppose you are 200 students in Bangabandhu College in mathematics department, and in a class, suppose some students are absent there. So how we can calculate how many students are present there? So at first you have to find by roll or alternative way how many students are absent there. You have to count how many students are absent there. Then if you deduct this number from total number, then you will get how many students present there. In this case, we have to find if the function is easy, either to find out the definite value of x or undefined value of x, which is very easy to you. You have to proceed in this way, which is very easy to you. So in this case, it's very easy for us to find the undefined values. So at first we have to find the undefined values, that is here 3, and so defined values will be deduction of 3 from total real number. So the domain of this function is r equal to 3. Next, second option, f of x equal x minus 2 by x square minus 4. Here we can write the same way. What can you write here? We can write here the function is here x square minus 4 if x square minus 4 equals 0 or x equal plus minus 2, then f of x is undefined. So these two values plus or minus 2, these values are undefined for this function. So what are the defined function? You have to deduct these two values from total real number. So here domain f will be total real number r and deduct minus 2 plus 2 from both. Okay, in this way we can find the domain of this function. You have to make restriction of x square plus 3x plus 2 equal to 0, then find out the undefined variable of x, and if you deduct these values from total number, you will easily get the domain of the function, that means defined values. So you have to follow, you have to follow in this way. What is the rule? Which items is very easy for you? You can find the values, defined values or undefined values. Which will be easy for you? If defined values is very easy for you, then you can find out the defined values. If undefined values is very easy for you, then you can find out undefined values. Okay? So in denominator part, that means in fractional function, we have to find out the undefined values and then deduct these values from whole number. Now number 3 is square root types function, and we know that in square root types of function, in square root negative values are not defined, only 0 and positive values are defined. So we have to find out the ways. In this way we have to find out defined values. So in square root types function, it will be easy for us to find out the defined values, but in fractional types of function we have easy way to find out the undefined values. So category 3, square root types function. F of x root over x minus 3, f of x square minus 4, f of x 4 minus x square, f of x root over x square plus 3x plus 2. All are the forms of square root types function, and it's really true that at first you have to find which values of x is defined in the square root. So it is very easy for you. At first we can begin with first examples. F of x, here x minus 3, here if x minus 3 greater than equal to 0, then or x greater than equal to 3, then f of x is defined, and these defined values of x are domain of the function. So domain of f equal under set x such that x greater than or equal to 3, or this can be expressed as 3 to infinity, and this is closed interval. Second example, f of x root over x square minus 4. Here, if x square minus 4 greater than or equal to 0, then f of x is defined. That means x plus 2 into x plus minus 2 greater than or equal to 0. Then f of x is defined. Let here a and this is b. Two parts, two quantity or two values. If two values or quantities greater than or equal to 0, then we have the two assumptions. Number one, first value plus second value plus, result will be plus, first value minus second value minus, and the result will be, product will be minus. This is one assumption, and if it is less than touch function, then we have first term will be plus, second term will be minus, product will be minus. First term or first quantity will be minus, second quantity plus, then their product will be minus. These two types of assumption we have, and from these two types of assumption, which types of assumption will be applicable for this function or these relations and these inequalities? We have to consider this. Here greater than sign. So we have take this assumption, this ways, and here we can take if two products are positive, two quantities are positive, then result will be positive, or two quantities negative and their result will be positive. So here we can easily find this. If x plus 2 greater than or equal to 0 and x minus 2 greater than or equal to 0, or x plus 2 less than or equal to 0 and x minus 2 less than or equal to 0. The function will be defined for this. That means, that implies x greater than or equal to minus 2 and x minus 2 x greater than or equal to 2, this, or x less than or equal to minus 2, x less than or equal to minus 2, x less than or equal to minus 2, and x less than or equal to 2. Here we have to proceed in this way. Suppose this is our curve and this is 0, here minus 2, here 2. So what is here? X greater than or equal to minus 2. That means greater than or equal to minus 2. All values will be satisfied from minus 2 and positive direction. On the other hand, x greater than or equal to 2. All values start from 2 and all positive values along positive direction. So what is their common part? This is their common part. The values which is greater than 2 also greater than minus 2. So it is easy that this result will be x greater than or equal to 2. Here are also you can take assumption from this x less than equal to minus 2. So this relation will be negative side. Also x less than equal to 2, this result will also along negative side. So what is their common fault? The values which are less than minus 2, also less than 2. So here we can write their common fault will be x less than equal to minus 2. So domain of the function will be x such that x less than equal to minus 2 or x greater than equal to 2. Also can be written as, it can be written as minus infinity to minus 2 union 2 to infinity. The same way we can find the domain of this function, and it is easily understand and it is easily be calculated, because here this system should be taken and here 4 minus x square greater than equal to 0, and if you multiply by minus sign you will get x square minus 4 less than equal to 0. Then you will take this assumption and you can easily find out the domain of the function. In this system you will be able to find the domain of all functions given here. Now four types of definition: square root types function, square mixed आकार function, mixed form of function, mixed form function, mixed form function. Here f of x equal x minus 2 x square minus 9 f of x x square minus 16 x minus 1 f of x x minus 5 x etc. In these types of functions we have to take the decision in this way. Here two functions, root x minus 2 and root over x square minus 4. At first you have to find the domain of this function and next domain of this function, and you have to intersect these two functions, and then you will be able to find the domain of the total function. So let f1 root over x minus 2 and f2 root over x square minus 4. Here we have already discussed. Here x minus if x minus 2 greater than equal to 0, then f of x is defined. F of x is defined. So if x greater than equal to 2, then f of x is defined. Hence df1 equal to infinity. Okay. On the other hand, here this is denominator part, so this will not be 0, and if it is 0, then the function will be undefined. So x square minus 4 never will be 0. So it will always greater than 0. So here if x square minus 4 greater than 0, then f of f2 x is defined. That means x minus 2 into x plus 2 greater than equal 0, then the function is defined. In the previous discussion we have already discussed that if two items of two quantity are greater than 0, then it will be two forms, and here we can easily take that -2 last 2 and and it will be less than -2 and greater than -2. So domain will be -2 minus infinity to -2 first bracket union 2 to infinity. So what is the total domain of the function? Domain f1 intersection domain f2. So here 2 to infinity, here 2 to infinity, here 2 to infinity. But in this part, these two parts, the intersection of these two parts will be easily found because here close interval, here open interval. Okay, here from 2 to infinity, but negative sign will not be accepted here because in these two part common part will be accepted. So it is easy, we can easily find that this value will be from 2 to infinity, but 2 will not be accepted here. So domain will be 2 to infinity and open. Okay, in this way you can also find the domain of all the given functions. Dear viewers and learners, I have tried my best to discuss vastly, but in this short time it's really tough for us.